over this poster that aims to help kids round. I'm not sure about you, but as an adult, I lost interest. Hi, I'm Sarah Porcenellic, and today we're jumping into NSO 1.4, the third grade standard, which calls for students to round whole numbers from 0 to 1,000 to the nearest 10 or 100. Looking at tools, resources, and posters, such as that one, we must ask ourselves as teachers, what purpose does it serve? What do you want students to know and understand by using the tool? For that resource, it feels as though the purpose is for students to memorize basic rules for rounding numbers. And if they forget, have something to look at to tell them what to do. However, is this what you want students to do? Just memorize? We want students to understand place value and number sense to be able to round a number, see the purpose and value in knowing how to round, and apply those mathematical rules seamlessly without memorizing a roller coaster or a fancy rhyme. Utilizing tools such as place value charts, 100s or 200s charts, number lines, or even physical manipulatives is a great place to start. But how can we supplement these tools in our teaching to push student thinking one step further? Using discourse in mathematics can help students process their thinking, and using questioning techniques is a critical part of the discourse. Research tells us that teachers in the United States tend to prohibit the use of errors and try to even hide them from students. But this can be the opposite of useful. So let's take a look at an example of how we can use errors to enhance learning. In this example, we ask students to round 739 to the nearest 10 and to the nearest 100. But remember, we're giving them it in context to help them process, understand, and connect it to the real world. In the classroom, we want students to feel comfortable making mistakes and value them in their learning. In rounding, students can often resort to guessing, chasing a correct answer, rather than focusing on their thinking and reasoning skills. Let's pretend you have a student with this answer. 739 rounded to the nearest 100 is 800, and rounded to the nearest 10 is 740. What mistakes do you think the student made? And how can we figure out what their thought process is without assuming? You may ask the following questions, such as, what tool can you use to prove your answer? Can you compare your answer to someone else's? What do you think that they were thinking? How about, what if the number was 732? Would that change your answers? Why or why not? That last one is key, because the students may have made an error when rounding to the nearest 100 by referring to the ones place rather than the tens place. So in that case, they may understand how to round up or down in terms of 0 through 4 and 5 through 9, but they don't understand which digit to refer to. If we don't get to the core of what students are thinking, we can't appropriately supplement their learning. You may also ask questions to elicit common errors and prepare ahead of time by anticipating student responses and how you'll respond to their thinking. For example, rounding 797 to the nearest 10 is one students often struggle with because it will change the hundreds place digit. Brainstorm how you'd respond if a student writes 790. What about 700? What about 800? The correct answer. If you work on a team of other teachers, discuss these tasks, possible student responses, and how you'll respond with one another. Collaboration can help us all be successful. This standard, although straightforward, can allow for a tremendous amount of critical thinking. Remember to ask questions of higher levels and give all students challenging tasks that require rounding. Check out the resource page for additional tips and thoughts on how you might be able to do this. Until next time, thanks for listening.